Here's another quick example using transformations. This is f of x is 1/4 to the x minus 2. So the base here, or the function that we're going to be transforming, is 1/4 to the x, meaning a is 1/4. The vertical shift is going to be down 2. Remember, shifts are adding and subtracting. I subtract 2, and it's not inside of my exponent, so it's going to be vertical, down 2. So for my points, so I'm going to start with my anchor points. My anchor points for 1/4 to the x. Then I'm going to do a vertical shift down 2. Okay. So my points are 1a, 0, 1, negative 1, 1 over a. So 1a, here a is 1/4. So 1, 1/4, 0, 1, negative 1, 1 over 1/4. And remember, the negative makes reciprocal. Reciprocal of 1/4 is 4. So those are the points I start with. If I want to shift down 2, I leave x alone. I subtract 2 from y. Leave x alone, subtract 2 from y. So instead of 1/4, I'm going to have negative 1 3/4, right? So that's negative 1.75. Instead of 0, 1, I have 1, negative 3. Instead of negative 1, 4, I have negative 1, 2. Okay, so these are the 3 points I'm going to plot. So stick those right there. Here's my graph. Can almost get them both on the screen. Okay, 1, negative 1.75. So that means I'm going to go down 1 and then 3/4. So 1, negative 1 and 3/4. So like right here. So almost 2. By the way I thought about doing this is if I had 0 minus 2, it would be negative 2. But I actually started with 1/4 more. So I have to go 1/4 less than negative 2, which is, 3/4. All right, then I do 0, negative 3. No. Sorry. This should be negative 1. 1 minus 2 is negative 1. All right, negative 1. And the reason that I realized I had made a mistake is my function was going to go down here. It was going to go down to here. I knew that wasn't going to be right. And then negative 1, 2. Okay. Now so this is going to go up to infinity. Now usually my function tends to 0 as I get, it would tend to 0 here. But I've already crossed 0, and as I get smaller and smaller, as I raise to larger powers of x, I'm doing more 1/4 times themselves. So this thing is going to 0 because I go to 1/16, 1/32, 1 over 64. So this thing is going to 0, and then I subtract 2. So actually, I'm going to tend to negative 2. So like this. And this is f of x equals 1/4 to the x minus 2 on the outside. Now, these two pictures, I thankfully have them next to each other, look very similar in terms of the overall shape, but the starting function looks different. So remember that 1/2 to the x is 2 to the negative 1, 2 to the negative x. So instead of thinking of this as 3 to the negative x, I could have thought of this as 1/3 to the positive x, which means it resembles this thing. So it has the same sort of behavior.